All right. Well, good morning, everyone. Welcome to day 4 of the GATK workshop here. This is the last day. Over the past few days, you've heard a lot about how we do somatic and germline variant calling, and we've walked through some exercises on Terra, and we're going to do a lot more hands-on stuff today, but to start with, we're going to talk about how we actually do our pipelining and how our services are actually executed through most of the processes that we do to go through our data and do our analysis. And the way that we do that is with these two constructs, Whittle and Cromwell. So when you're running a whole bunch of data sets together, you're probably going to want to process all of your data the same way each time so that you can do a proper comparison between all of the different data sets that you end up with. And the best way to do this is to have some kind of engine that can execute these tasks one after another in the same way each time automatically, so that you can kick off your analysis at the beginning with a raw data file and end up several steps later with a processed file that you can look at manually, with all of the steps in the middle being run on their own, that you don't have to worry about doing them individually. And if you can set up a pipeline like that, then you can run things more quickly. It reduces human error from copying and pasting things, and you can reuse these implementations later if you want to do the same analysis or a similar analysis on a brand new data set. So the first solution that we have for this is a way to describe how to run tasks in order. And the way that we do that is with something called Whittle, or workflow definition language. What this is, and you see an example of it here, and I'll walk through it in a second, but it's basically a description of how to run different pieces of software, how to define their inputs and how to define their outputs, and how to plug them together into a pipeline so that instead of you running things on the command line with bash or some other script that you've written yourself, you can define self-defined and encapsulated tasks that do simple things on your data and chain them together using this high-level language instead. And by doing that, you can define common tasks once and then refer to them later over and over and over again, so that you can just reuse these tasks that you've already built. So what this means and what it looks like is that it's easier to run your data. But Whittle is broken up into full workflows that will do a series of tasks one after another on your data, sometimes taking input from one task into another, like some of the intermediate steps in a pipeline, and then giving you some output at the end. And then this workflow, like I said, will call each of these tasks that will actually run some command and produce an output. And these tasks represent the individual tools that you would run in a pipeline, and this workflow represents the whole pipeline itself, usually. You can chain workflows together the same way you can chain tasks, and it is actually very flexible if you want to edit it or add it or change things in your workflows. So like I said, you can chain things together differently depending on how you want to use them. You can very simply call a whole bunch of tasks in series. So you call the first thing, and then you call the second thing with the input from the results of step A. And similarly, you can put the results from step B into C, and you can see that step A's output goes to the input in B, B into C, and so forth. And really, any combination of the things that you could think of to plug files in for input and output and combine different inputs and outputs are things you can do in Whittle. So You can have multiple input files that are processed in parallel or in series. And that's what these two things are, where you've got sort of a scatter-gather or a parallel processing framework that then gets aggregated out. As an example, if you wanted to call germline variants over the whole genome, you could probably safely do that on each contig individually because you're not expecting there to be any contiguity between them. So if you wanted to run it 23 or 24 times faster, you could break everything up by chromosome and then you would get your file output much more quickly. And it's relatively easy to define all of these different execution methods in Whittle. And so I'm guessing you're not familiar with Whittle to begin with. Has anyone used Whittle before? No, okay. So you don't have, this is all new, but the way we usually present this is, you know, we've made some changes to Whittle, but since you've never used it before, you can use it to work on files in the cloud with NIO, which is usually how we do this, and it's very, very helpful. And we've added a whole bunch of other features that make it much more easy to deal with and work with in a way that's a little bit more natural when it comes to building up pipelines and frameworks for pipelines in Whittle. So we can look at a very short and simple example of a Whittle task. And this is the canonical hello world example. You have your command block here, which is what's actually going to run inside a Docker container. And it's just going to run hello world, echo hello world, which runs at the command line. So this is actually a bash command that you're ending up running. More importantly, with Whittle, we can define the runtime parameters for the execution environment that we want. So if you know that your task only needs 10 megabytes of memory, you could put 10 megabytes here and it would be fine. Similarly, you can express your disk usage and your disk size and whether you want it to be preemptible. We work on Google Cloud most of the time, so these are all parameters that end up on Google Cloud. But what this gives you is a way to define your runtime environment for the particular task, and under the hood, what will end up happening, once we get to Cromwell, this will make a little bit more sense, but when you run a Whittle, the first thing that happens, or one of the first things that happens, is your runtime environment gets created on the server, including standing up a Docker image and running the Docker image with whatever settings you give it for disk size and memory. So this all happens automatically for you if you set it up the way we've got it set up in Google Cloud. So you don't have to worry about machine allocation or anything. You can run these things locally as well, but it becomes really, really nice to be able to set your runtime environment like this so that you can more easily distribute your resources in a way to package things in ultimately as small and therefore as inexpensive a way as possible. So I've just talked a lot about Whittle, and I mentioned this Cromwell thing. Well, Cromwell is what interprets your Whittle and actually stands up your environment and executes the jobs that you've defined. So Cromwell is, in that sense, an execution engine or an execution service. This pig with warp nacelles is its mascot. And as I said, you can stand it up locally if you like. Typically, we run it on Google Cloud. This either way will do things like look at your Whittle, look at the runtime, stand up the Docker that you need with the resources you've described. If you do it locally, you can do it on a cluster, and it will do the same thing. In Google Cloud, what will actually happen is it will grab resources from Google that are sufficient to run the container that you've asked for, rather than pulling some resources from the local cluster. It's sort of the same idea, but with Google Cloud, it will actually dynamically create and then destroy your the Google execution machines for you. So you don't have to worry about telling Google, oh, I need this machine, and then, oh, I've got to put Docker on it, oh, I've got to put my Docker image on it. Cromwell will do all of that for you. So you just have to have it defined in the Whittle in the first place, and then you can run it on Google Cloud. And that goes the same for the local cluster as well, if you've got everything set up and installed for Cromwell correctly. So typically we run in server mode because we're running a lot of jobs. But if you were so inclined, you could also run it for a one-off simple self-contained run and give it your Whittle, and then your inputs are in a JSON format so that you can read them as a human being, but it also is easily interpretable by the machine. I've actually never seen this done, so it might be useful if you haven't got a Cromwell server, but because we have a few of them in the office, I'm usually just talking to the API endpoint for Cromwell to run my jobs and set them up and then look at the results. Something else that's actually really, really nice is this call caching. And what call caching will do for you is, let's say you've got a pipeline and halfway through the pipeline something happens. Your job number 5 out of 10 broke. And you've got the results from jobs 1, 2, 3, and 4, but 5 through 10 just haven't been run. Now, without call caching, you'd have to rerun the whole workflow, and you'd have to rerun those jobs that you've already got the output for. You've already spent time and maybe money getting those results. Wouldn't it be nice if the machine would recognize that those have already been calculated and use the outputs that have already been saved? And that's exactly what call caching does. If you try to execute something that has exactly the same inputs, exactly the same workflow, and exactly the same container that you've already tried to run before, and it's run to completion and successfully, then it won't run it. It will say that it's complete, and it will point you at the results that you've already got. So it saves some time, it saves some money as well, and it's really, really nice. There are times when you don't want call caching on, like if you're looking at performance testing, but by and large we keep it on because we like to not do the same thing twice. There are some command line tools that go along with building a Whittle and with Cromwell. Specifically this WOM tool, and I don't remember what WOM in this case stands for, workflow something, or Whittle something. But some of the things that this jar will do for you is it allows you to validate your Whittles that you've created. So like any other programming language, you write something, you try to compile, and it breaks. Well, in this case, it would be you write something, you try to execute it, and then it fails. So instead of going through that loop of, you know, oh, I forgot a semicolon or I forgot a closing brace or something, you could just have it validate the file, and then you know immediately what the error is, and you can go in and fix it. Similarly, since each Whittle specifies what its inputs are supposed to be, you can generate this placeholder inputs file that will have all of the possible inputs for your workflow. And then you just have to fill in the blanks for what you actually want your inputs to be. It's very nice to do that because then you don't have to worry about copying and pasting the input names and getting something wrong there, and then you also have a failed execution. Yes?
That actually gets you, I'm sorry, that gets you a structured JSON file, or it gives you so it gives you the structure of a JSON file. It doesn't give you a filled-in JSON file with the inputs. I might have gotten lost in there.
No, you're right. It gives you a structured JSON file where usually the JSON files are very, very simple. But it will give you, a JSON file with all of the input names, and then like input name X equals, and then in quotes the type. Because it doesn't know a priori what the inputs should be, but it knows what their types are. So it'll give you the full input name as expected, and then as its value, the type that then you have to fill in with whatever the correct value would be. But the benefit of that is you don't have to copy and paste the input names into a new file somewhere and figure out if you're missing an input or something. You can generate this template file from the Whittle itself.
Okay.
So, and yeah, that's a good way to think about it. It generates an input template file that you have to fill in. Or at least that's the best way to think about it. That's the way I think about it. And then obviously you can run your Whittle and your JSON, your workflow with Cromwell once you're done, and get your results, and everything should be good. And that's it for a very brief introduction to Whittles and Cromwell and how we do our execution. And I should say that we use Whittle and Cromwell for pretty much everything that we do at this point, because it's automated and because it's easy to kick off in terms of data analysis. Any questions about Whittle and Cromwell? Okay. What's next? I don't remember. Yes, that's right.
All right. So next up, we're going to get hands-on with Whittle. We just saw a PowerPoint presentation about what the structure is, but we're going to poke into some real Whittles and see how you can build them piece by piece. So in order to do that, I want you to go to, the URL is broad.io/GATK2002, and that'll take you to your folder where you have all of the materials. We're going to be in the exercises folder right now. And specifically, we're going to open up this Hello Whittle tutorial. So the instructions are right here. I have them printed out to save space on my screen, but you can continue to reference back to them if you're having trouble keeping up with what I'm doing. And you can always take it home and work with it there. So the very first thing we're going to do is go to our bundle that we downloaded. And there's a folder called scripts there. And the first one we're going to open up is Hello World 0. So I'm opening this up in a program called Sublime Text, which was in the installation instructions to install. Another part of the install instructions was to optionally install something called syntax formatting. And what that does is it highlights the words in the various colors and formats them so that you can see them more easily and understand what the language is. if your screen just has all the text appearing white, it's still working, it's fine. But the syntax highlighting gives you a little bit extra to look at. We have a variety of syntax highlighters for some other programs you might use to write code in. So if you're more familiar with a different program that you want to use, you can feel free to use that. I just always use Sublime Text here because typically not everybody is a programmer, and some of the higher level programming tools can be pretty complicated. This one's basic and nice and simple to work with.
The Visual Studio Code application has a plugin for Whittle,
Yep.
which will do the syntax validation and everything. It's free, and I've heard it's very easy to work with.
Yeah. IntelliJ, Visual Studio. All right, so we should have Sublime Text or whatever text editor of your choice opened up with the file now. The next part to set up is our terminal window. So I've opened up a bash terminal here, and let me know throughout the day if any of the text is too small. I've zoomed it in, so I hope it's good. My first step in my bash terminal is going to be to launch Docker. If you don't have Docker, it didn't work for you, don't do this part. Don't worry about this part. So I am just going to run my Docker quick start, which I can't find. There it is. So I just clicked on Docker to run it, and it's put a little whale icon up in the corner. It's asking me to install an update, but I'm not going to do that right now. Just because I don't want to wait for it to download. So this icon up here is what's indicating to me that my Docker is starting up, and then when the little icons stop moving, it means it's started. And that means in my bash terminal now I can open up Docker. So the command to do that is this one. It's on the very first page, so if you're following along with me, you can copy it there. In the command, it tells you to give the path to your GATK bundle. So for me, that is, actually let me just open up a Finder window. So for me, it's on the desktop under GATK bundle, scripts, or well, that's the whole thing, but under GATK bundle. So for my purposes, I'm going to go So if I navigate to the directory where my bundle is, I can use the command pwd, which stands for print working directory, to print the directory where my bundle lives, and then I can just copy that. So real quick, I'm going to just copy it over onto this side so I can easily remember it, and then I can do the Docker command. All right, so that is what my command looks like here. The things I changed compared to what was in the PDF copy you guys have is instead of it saying literally path to GATK bundle, I inserted the path where it was. Everything else is exactly the same. So it's telling Docker to run, and it's telling it to grab this folder and mount it to this location on this image. So we're using the Docker image GATK 4.1.4.1. And if you don't already have that image pulled, it would then start pulling the image here. But since that takes a while, especially with slow internet, we've had you do that in advance. So mine just opens straight up, and you can tell I'm now in the Docker because it tells me, instead of up here where it says the WM074, which is my computer's ID, it tells me I'm in a GATK Docker. I'm at the location root with some string hash there, specifically inside the GATK folder. So if I type ls, I can see the structure of my folder inside. I have my GATK here, which I'm going to be able to call and work with. And then I have my data, which is the folder that we mounted here. So if I navigate into my data, I'm going to type cd my underscore data and hit enter. I'm now, clear my screen, I'm now not in the GATK folder, I'm in the my data folder. And if I type ls to show what's in my directory, you can see it says data, jars, puzzle, scripts, Terra. And if you recall, that is exactly what we're expecting to see inside our bundle. So for those of you who aren't in a Docker, all I need you to do is navigate to the directory in your terminal window. You're going to change directory to whatever directory is your GATK bundle. So when you type ls, I want it to say data, jars, puzzle, scripts, Terra. And raise your hand if you have any trouble or need help. The root, to say root here. So that's because I'm inside the Docker image and it's telling me I'm at root location. Are you able to use Docker or no? I'm the root user? Okay.
I first make the command in this window to make the root or what? Because I get lost in that part to try to do with the hello board, and then I don't know what do you do, and then just get the root. So
Do you have Docker? Yes, you do. Okay, and then did you run that first command, Docker run? So I'm just typing those commands as record. All you need to do is type this command up here in your terminal window.
in the terminal,
Yes.
and in what folder?
You can run it from any folder. The important part is, see where it says users Knoblet desktop, it should be whatever path your bundle is installed into on your computer.
Desktop, just go to desktop.
That is the part that I messed up.
Yeah, no problem.
I need to get the right folder, right? But
get the right folder. Yeah, so close that and do PWD. So you will want all the way up through 2002. So don't add the scripts part, but yeah. Yep, like that.
That's the part that I miss it.
Okay, and then you'll want to delete that last one. Yep. Okay.
Come all the way to the carpet look at the right at less.
Okay, so it looks like it didn't mount it properly. Is this right? Okay, so the part you were missing, so this is the location where the bundle you want to mount is. You need to specify where you want to mount it to. So you have that :GATK/my data or /GATK/my data. That's the part you need to add in. So you should be able to copy that and then insert it.
I think that is downloading something. This is correct.
Yes, so you didn't pull the Docker image beforehand, so it's going to be downloading the Docker image probably for maybe 30 minutes to an hour. So I would suggest just
this one.
you have that Docker image
Yeah.
already? So this isn't the Docker image, this is the bundle.
Okay.
The Docker image is over here. It's the Broad Institute 4141.
Yeah. The
Yeah.
program say that doesn't find locally. Is that happening?
Yeah, so that
No,
happens the
not
first
already.
time. The first time you run Docker, you have to run a Docker pull command.
Okay.
And since you didn't, it's pulling it now.
Okay, I need to wait this one and then
Yeah.
do that.
So right now it's pulling the image and then it'll open up and then you'll be where I am. Yeah, it'll just take a while, so I suggest following along just with what I'm working on. And then you can catch up either using the directions on the PDF that I gave you guys.
PDF
Yep.
with all the material.
Yeah, so where the materials are, under exercises. So it'll be the Hello tutorial.
Ah, okay.
So I'm
I
just going
hope
through
this
that.
one I relate a lot.
Okay.
Thank you so much.
All right, how's it going? Are people able to get to this directory? Okay? Anybody need help? Yeah? Help still?
So I have my these data in a folder, and I try to get to the directory, but I can't. This is the directory, and I try to change everything, but it says it's an invalid reference format.
Okay. So it looks like the format you want, instead of C:// you want /C/.
Okay,
So replace it with that and then do the rest of the file path the same. You may also need to wrap it in quotation marks because it doesn't like when there's spaces.
Okay.
Or you can change the name of the folder to not have spaces.
Okay, thank you.
Okay.
That looks, this is 4.1.4.1, and the other one I thought was 4.0 something. Can you go back to your terminal? Yeah, that's 4.0.
Can I stop this? Because I think
I'm changing the.
The name?
Yeah, so I can.
Turn up here so slow.
Yeah,
There haven't been a lot of significant changes between the So if you hit Control C,
Ve, esto me pasa por tener todo ordenado. Guión bajo. Ok. Y esto también.
it's ready. Yeah, and then we'll just change that version number to the one you're using.
Yo creo que ya nos vamos. Hay que cambiar esto.
So anyway, since we just started, why don't you cancel that? And then type Docker space images. In the terminal, type Docker space images. Yeah, you can just start from scratch. Yeah. No, images, IMAGES.
So you still need, oh,
Ah, this one.
oh, it worked.
You have
It's pulling the image.
4.1.3.0.
So it looks like you hadn't pulled the image before, so it's pulling it now.
Not have to download.
I thought I did, but okay.
Can I copy this or I have to write it again?
I don't know how this terminal works, but I just like to do the up arrow and then it'll put
Okay.
that, yeah, and then you can change the number.
Yo veía las instrucciones y yo lo hice.
Should just be required.
All right, so I think most of you are able to be getting in there. A few of you are downloading or are pulling the Docker image, so that's going to take a bit. I recommend following along with me up here, and then you can absolutely reference back to this PDF to catch up with commands. It's really just you can jump in later. You don't have to have run everything to get to the point where I'm at. So you should all be in your My Data folder, or if you're on your local directory, you should be just in your bundle folder. But either way, when you type ls, you should get data, jars, puzzles, scripts, Terra. So the very first script we're going to run is this Hello World 0. It's a very simple workflow where we only call one task, which is called write greeting. In that task, we have a command which echoes the string hello world. For anybody who's familiar with programming, this is a pretty typical first example we give you, just to echo hello world. And then we're going to write the output of that, which is going to be our hello world echo, to a file we're calling out file, and we're going to pull from the standard out. So essentially, this script is going to print hello world, and we're going to capture that into an output file. So let's see it work. To run this, I'm using the command about midway through on page 2. And I'm also going to type the command up here for you to copy. I'm typing my commands in this Sublime Text window so that you can copy them at any point and see what order I've run things in. But the terminal window is where you're running them. I will also warn you, you all have access to the PDF and the commands are on the PDF. However, I wouldn't recommend copying from the PDF. There are invisible characters it will insert, and it will cause your command to fail confusingly. So we recommend that you type them. Yep. This one. Yes, so you should write it in your terminal window here where you have Docker open. So if I scroll up, I can show you where I did that, right here. So I just wrote it in here and then ran it. I'm just copying it in here for you guys to copy from. So the command we're using to run this script uses the Cromwell jar file. So in order to call any jar file, you do java-jar, and then you specify the jar file. We've included this jar inside your bundle, so it was easiest to work with. Then we give the command run, and that's going to run a script. So we need to pass in a Whittle script, and for us, that's hello world 0.whittle. So this is the most basic command structure for running a script in Cromwell. There's a lot more options you can add, and we'll see a few more of those later. When you enter this command, you'll notice that a lot of stuff prints to your terminal, a lot more than just that echo hello world. And this is the information that Cromwell itself is outputting to you to give you information about what it's doing. To us as humans, it's not necessarily as useful, but for servers or for working with Terra is able to use this information and parse it and work with it. The important parts of this that I think you should look at, I'm going to scroll through real quick. You'll see this pink text here. This is the command that it's running. So for us, we gave the command echo hello world, which is good that that matches what we gave it. And then the next bit to look at is this output section. So you see here it says workflow hello world complete, final outputs, and then inside some curly braces you have your output file specified. So you have hello world.writeGreeting.out file. So that's our workflow, our task specifically where we had the output, and then the output name. And then it gives you the link to what your output file is. So I'm going to copy that link here with just a copy, and go all the way down to where my return is, and just clear my screen. So to open that up, there's a couple different ways you can do it. I think this is the easiest, so I'm going to show you it first. I type more, and then I do a paste to paste in my file path. The more command, for those of you who aren't familiar, it's going to open up the file, but only show as much as can fit on the screen at one time, and then you can scroll through it. So when I run this, there's only one line in it, so it fit on the screen well enough. But you can see that the contents of that standard out file is simply hello world. So our workflow ran, it worked. It gave us a hello world output. The other way you can do this is by going to your, so for Mac it's called Finder. I think for Windows it's a file browser, but wherever you go to look at files. And then inside your bundle, you'll notice you have 2 new folders in there. These folders were auto-generated when you ran Cromwell for the first time. If you follow the path listed in your directory here, so we have my data Cromwell executions. So we're going to go to the Cromwell executions folder. Then under hello world, then you have this long string of numbers and letters. This is the hash ID of that particular workflow run. So if I were to run this exact same command again, rather than overwrite my previous results, it's going to generate a new hash number like that and then output the results there. And in that way, you can run a workflow multiple times without saving over your results every time. So we're going to go into that one. It breaks the workflow out by the different calls to tasks. Ours only has one call, so it'll be call write greeting. And then it looks like it's under the execution directory and then the standard out file. So if I open this up, and I'm going to just open it with text edit, it says hello world. So that's another way you could check the output, is by literally navigating through the folder structure. But it is a lot of folder structure to go through, so that's why I like the more command. It seems easier to me. We're going to close that. And next, we're going to go open up another script. So we've looked at hello world 0. Now we're going to look at hello world 1. So comparing it to hello world 0, if I scroll this over a bit, comparing it to hello world 0 on the right, you have hello world 1 on the left. We've added one thing to this, and that is an input. So our new line here is this string greeting. Inputs can be a variety of different types. This particular type is a string, which means it's going to be a line of text. And then to reference that variable we've declared, so this is an input variable, instead of calling echo hello world, we now call echo greeting. And then to tell Cromwell that this greeting is not just another word that we want to print, it's a variable, we wrap it in this $, curly brace notation. This is the notation used in Whittle draft specs, which is what this was originally written for. It can also be used in current Whittles, but another notation that you might see instead of this $, is a, is this a tilde? Not sure, little squiggle. This is another notation you can use to reference variables. So we're just going to leave that as a $, right now. And since we're passing in an input, we need to specify the value of those inputs. So I'm just closing hello world 0 right now. And going over to my Finder, and you'll see that there's already an inputs file generated for you. So it's called helloworld.inputs.json. And I'm just going to open that up in Sublime Text. And you can see this is the structure of a JSON file. It's given to you in a key value pair. So everything before the colon is your key. Everything after the colon is your value. So on this side, we see the declaration of what the variable is, broken down by workflow, task, variable name. And that's important because you can have variables of the same name in different tasks. You can have variables at the workflow level, not at the task level. So it gives a breakdown of where you would find this variable. And then over on this side, wrapped in quotations, is the value we want to put in there. So now when we run this workflow, we should get the output of hello workshop instead of hello world. So let's do that. I go over to my commands. So you should type this in your terminal window. I'm going to type it over on my commands window here so you can copy it more easily. I am looking at the command on page 3, about midway down. So the thing we've added to this command here is a -I at the end. So I stands for input, and we're passing in this inputs JSON to it. When you have a script that doesn't need an inputs file, there are no variables in it, we are able to run without a -I, but in I'd say 99% of cases, you're going to have inputs that you're passing into your workflow, so you'll need to specify a -I. Yep, run that in the terminal. And raise your hand if you need any help, having any trouble hitting an error. These are all perfectly normal. Does anyone need any help? We good? Yeah, so the output is going to go in your same executions directory, but it's got a new run of it because it's the same workflow name. All right, so you should have by now been able to run this. And there's a few changes since last time. After running it, you should get this pink text here. And you'll notice that it doesn't say echo greeting. It says echo hello workshop. So this is your rendered version of what you put in the command. It means it's reading in your inputs file and compiling it. So if you were to see an error after that, you would notice that, oh yeah, that line looks weird, or I forgot to wrap it in quotes the right way, something like that. Then the output file is here. And if I copy that and clear this and then paste it, type more, then paste it, I'm going to get the text that's in the file, which is hello workshop. So that means it ran successfully. And then one thing I was just pointing out before we got back together was that the hello world workflow was run for a second time. So in spite of this being a different script, the workflow name itself is still the same. It's called hello world, which means it went under this same hello world folder, but now you have a second folder in there with its second hash string. So the outputs didn't overwrite each other, and we could still access the old outputs. Any questions on that? Adding in an input variable? Okay. Then our last hello world example is going to be hello world 2. So if I open that up and put hello world 1 next to it, this one looks like we added a lot, right? It's a lot more text. But really all we've done is add one task. So our write greeting is still here, but in our workflow we've added a second call. So our new call is to a task called read it back to me, which takes as an input the original greeting, which we're pulling from the previous task. So this is saying, look at the write greeting tasks, out, and use it as the input. So if I go down to read it back to me here, you see that I take in a string original greeting, which makes sense because in order to have an original greeting up here, I have to declare it in the task. And then in the command, what we're telling it to do is to say original greeting to you too, and then write the output again to an output file. So since we want to pass a string value from one task to another, we've also changed this output from write greeting. So instead of it saying file out file equals standard out like it did before, we're now saving it to a variable. And we can do that because we're passing it to the next task. We don't need to open up a file at the end. And we're using this string out as our variable that we're going to watch. And then we're using a library function of Whittle called readString from standard out. So what that's going to do is look at the standard out file that's written by default because Echo is writing to a standard out. That's what it's telling it to do. It's going to look at that standard out file, and it's going to read a string from that and save it as a string variable, which is our string out. There are a lot of library functions available to you in Whittle, and you can look at those by just looking at the spec, which we will link in the email we send you after the workshop. But you can always find it by just Googling Whittle spec. All right, So then the last thing to mention here is that I have this new output section in our workflow. So since we have two tasks, we have two outputs. We have an output from the first task and an output from the second task. However, I only care about the output from the last task. I don't want to keep track of all the other outputs. So by default, if you don't specify an output block in your workflow, then the outputs that come up here in your terminal, where it prints the outputs, it's going to be all of the outputs that were generated from all of the tasks, which at a pipeline of 2 tasks is not that much, but at a pipeline of maybe a parallelized task where you run it 1,000 spread, that's 1,000 different files. You don't want that. So we can use this output section to say, the one I care about you reporting back to me is this one. So the output of my workflow is this one, and that's the one I want you to tell me about. So let's run this one. And an interesting thing here is that we have 2 variables declared, string greeting and string original greeting. But since original greeting is given a value by a previous task, the only input to the workflow itself is just this greeting. So we can use the same input file we just used. So we're going to do that. So here's the command, and there's actually a quick way to get it if you want. If you type the up arrow for your arrow keys and go back to the command you just ran, which is this one, and then you use your back arrow to go back to the script, you're just going to change the 1 to a 2, and then you'll be able to run that. Okay, so that should run pretty quickly. And as it's running, you'll notice that there are 2 bits of pink text in there. The first one says echo hello workshop, and that's from our first task. The second one says echo hello workshop to you too. And that's the second task's command. If I scroll all the way down to our output section, you'll notice that it only gives one output like we predicted. It gives you the out file of the workflow and the link to it. So if I copy that again, we're going to use more to view what's in it. So copy it, clear the screen, more, paste. So the value inside that file is hello workshop 2.2. So it worked. Is everybody able to do this for themselves? Worked out good? No? Do you need help, or are we? Okay, working on it. All right. This is all well and good, but we've given you some nice whittles that we know work. What happens if you're writing your own whittle and inevitably there's going to be bugs? So how are you going to troubleshoot bugs or work with it and figure it out? So one of our tools, the WOM tool jar, has a number of functions to it that you can use to help validate your script. So let's say when you were writing this script, instead of saying string greeting, at one point maybe you just said string greetings with an S, and you typed it string greetings, but you called it string greeting like that. Simple mistake. So I'm going to save this file, and that's important because if you introduce an error, you have to save it. Otherwise, this won't call an error. And then we're going to use WOM-tool, the validate command, to test and see if it'll catch it. So WOM-tool's command is in the lower half of the page on page 4. You'll notice that I'm using WOM-tool-48 and not Cromwell-48. And you're going to use the command validate and call it on your script. So let's copy that. You can paste that and run it when you're ready. So when you run it, Validate is going to go through and check for any type of syntax errors, anything it can find that Whittle should know about being broken. So what it found was that the variable greeting here doesn't reference any declaration in the task. So it's saying that if you look in this task, we never declared this variable that we're calling. So what's going on? And if I go back to my script here, yes, we didn't actually declare greeting, we declared greetings. So let's delete that S, save it again, and then we'll just rerun that validate command to make sure that it's gone. Success. So if it found no syntax errors in your script, then you'll get a success message like that. It used to print out nothing, but we got feedback that that wasn't helpful. We want to know when we did something right. All right. So let's look at another error. So let's try changing it from string greeting to maybe int greeting. So this is, you put a different type in than it was expecting. So instead of expecting a string, now it's expecting an integer. But we're handing it a string, so what does that mean? So in order to test this one, we need to first save it, which I almost forgot. We're going to pull up the last validate command, and we're going to run it. Now that one gave us a success message, and that's because it could be you could be handing in an integer. But let's check it now with our inputs file and see if it complains about that. So if I add a -i for scripts, hello world.inputs.json, and I run that, this will give an error. Failed to evaluate input for write greeting.greeting for input string hello workshop. So it's saying we couldn't evaluate the input string that you gave us. And that would be a clue for you to take a look at your inputs file to make sure that this is the string you indeed want to put in, and then check your Whittle and make sure that it's expecting the right type. So we'll change that back. And there we go. Now, another thing that WOM-tool can do is generate an inputs file for you. So we're going to try that and see, and go and fill out our own inputs JSON. So to do that, the command is java-jar, jars WOM-tool. And the command you're using is inputs. And then you use a greater than symbol, and you're going to give it the name of the new file you want it to create. So I'm just giving it this new file name so that it doesn't overwrite my other inputs JSON in there. And this task, when you run it, it doesn't print anything out to the terminal. It doesn't do anything, but it should return fairly quickly. So go ahead and run that. I'll give you a minute. All right, so when you've run this, if you go to your Finder or file browser window, you'll notice that there's a new inputs file in your scripts folder that wasn't there before. So it'll be called helloworld_2.inputs.json. And if I open it up in Sublime Text, this is what it generates by default. So it tells you the key, so it knows exactly what workflow, task, and variable name. And then it tells you the type it's expecting on the other side. So it doesn't fill in the values for you, but it tells you what type of value it's expecting at that location. This is also really important because if you have a workflow that runs 100 different tasks with, like, I don't know, 5 variables a task, it's going to go through and find exactly which variables don't have a value from a previous task and give you the ones that you need to input into the workflow itself. So again, this one found that you just needed to declare the greeting from write greeting. You didn't need to declare original greeting for the read it back to me task because it's pulling that from a previous task. So now it tells you you need to fill this out. So everybody fill in a string. What greeting do you want to give? I hear this one's a common one. Yeah? Did I spell it right? Okay. All right, and then I'm just going to save that so that it remembers it. I'm going to go back to my commands, and we're going to rerun this command here, but we're going to change it from hello world to hello world_2 for our inputs JSON. Like that. So we're running this then with our new inputs JSON. So it's echo pura vida is the text it rendered, and then pura vida to 2. And then in the final outputs, it gives you a directory to open up. So I'm going to scroll back up to those outputs, copy this here, and open that up. And you can see that it did capture my new input. Question? Sorry? No. Yeah? It's locked?
Yeah. I don't know. It's the same with the
Can you?
with the Chrome expressions.
What happens? Can you like right click unlock it or something? not sure. I've never seen that before.
And you don't have permissions.
Yeah, it looks
You
like
can
you created the file without giving yourself permission to edit it, but I don't know how you do that.
Maybe you can change the permissions of the file.
If you know how to change the permissions, do you know how to change permissions for a file?
Really?
Yeah.
You can
I have the same permission denied.
Ah,
I don't know.
hey Laura, do you know how to edit permissions of files? The file they create gives them a permission access denied error. This one looks like or Linux, and that's a Mac. But they're both getting that error.
On the outputs?
Yeah, so the file they created, the Hello World inputs 2
Oh, from the,
from Docker.
I mean, the classic is chmod.
Yeah?
Oh, okay, so if you just type in a path like that tries to run the file, say you wanna do like a less or cat or something to view it.
Hmm. Okay, well then his behind you has the permission error on the, right there. Has the permissions error. I thought it was the same error.
Yeah, he said something funky with the qualifications.
Maybe that's the same.
Well, it's pretty, you can change that. I don't know if you created it recently. I think if you just go to the properties and on the file,
No sé, man, es que no sé, yo le metí el JSON a los dos.
that sounds, I usually do E plus RWX or just RW.
I think 700 actually all access or
I thought that
700.
was 666.
No, yeah, that's well, that,
Yeah,
we
that's
use
the
that
one that
we
we
use
should
that
not
seed.
use.
We use that seed for our machine learning experiments. We got a bad seed, but ¿cuál es todos los proyectos?
Absolutamente todos, para todo el mundo. O sea, es que el problema es que es para todos. Entonces, cualquiera se puede meter ahí. Es endless.
CH mod. Sí, CH mod. Chimar. Sí, entonces ahí se dice. Bueno, smart, o sea, no,
Sí, o sea, lo puedo utilizar con
CH mod 700.
y 700 es DCLab, que es read, write, execute. Entonces, está
Sí,
perdido.
creo que es CH mod 700.
Pero, o sea, sí, sí te entiendo, pero aquí nada más en la línea 4 es
Sí, bueno, el nombre del archivo. Bueno, es que se me olvida el nombre del archivo.
sí, pero digamos, poner todo el comando, o sea, la dirección, y luego se ha hecho.
No, porque esto está, o sea, esto está en el path file.
No, porque estoy en my data.
Sí, pero en my data está el nombre del archivo. Entonces tiene que agregar el path, pero agregarlo con chancho.
Okay, so I'm seeing a couple people have some errors, so we're going to continue to work on those. But I wanted to give you guys a break to go grab coffee. We're going to break until 11, and then we'll come back with more of this. So don't shut down your Docker or anything. You can close your laptop, but we'll be back to the same stuff right after the break. So I'll see you guys at 11. These commands? Yep.
Pero entonces no ponga cuál
when it finishes running, in the output section, you should see again that file path to your final output. You'll notice that it ends with mother.gvcf, which is our expected file name. So we're going to copy it and then use the more command to look inside it. So this is an example where the file is bigger than the length of the screen. So you'll see at the bottom it says more 0%. I think that's the amount of the file we've read through so far. It's a very large file. And we're just going to scroll through and see that this does in fact look like a GVCF like we'd expect. You scroll through by hitting enter and it'll just go down one line at a time. So I'm just holding it. So this is the header of our GVCF file. And this is our GVCF block section. So that would indicate to me that this is in fact a GVCF file and not a VCF. And eventually I'm going to get down to some variants. There we go. So these are our non-ref blocks here. And if I continue to scroll, I think I should get to a variant site. There's one. So right down here, this one is an example of a variant where it's got some more information in it. It's a A in the reference, and it looks like an ACT in the alternate allele. So it did, in fact, go and create a GVCF for us with this task. Any questions on this? Okay.
What did you print?
What did I print?
What did you show in that?
So I typed more, and then I copied the output link. Yep. And that's how you get this view. To exit this view, because it's not entirely obvious, you hit Q, simply the Q key on your keyboard. And then you'll get your handle back like this, and that means you're allowed to type more commands. So we're going to type clear our screen. Now let's say while you were writing your command, you got up and got a cup of coffee, and then your cat came over and ran across your keyboard like that. And let's say you didn't notice, and so you saved it, and you decided to run it. So I'm going to run this just like that. It's going to start up for a bit. It's going to try and run. It's going to show me my rendered command was not right. And then it'll tell you that it hit an error. So here we go. Here's the error code. So it said it exited with return code 2, which has not been declared as a valid return code. Check the contents of the standard error file for potential additional information. And it gives you a link to that standard error file. It also outputs the first 300 bytes of the error file here. So for us, it tells us usage, program name, available programs. It's not terribly obvious what's going on. So let's just open up that standard error file first. And then an unfortunate side effect of it only printing out the first 300 bytes is that it likes to turn it all gray because there's some formatting going on in the output for that one. Let me just reopen this real quick. All right, so when I type more and open up the standard error file, I get this output here, which is our usage, program name, available programs. So this is telling me when you run GATK and you run it with a tool that's not in existence, it tells you, hey, no, these are the programs I have. This is what you can use. So this would indicate to me that something was wrong with the tool I tried to call. So if I exit this with Q, and apparently that still turns it gray. Hold on. All right, so then if I were to go back and look at my command, it indeed is not a real command. So we're going to fix that. Like that. Actually, before I fix it, best practices suggest that we should run a validate command on it. So let me just leave this broken for a second, like that. And we're going to try and run a validate command to see what validate has to say about it. So okay, so that didn't do exactly what I wanted it to do, to show you. So it's not supposed to fail, but because my cat accidentally typed a bracket, it was expecting a closed bracket, and it's throwing that error. Let me save this and try one more time. Oh, that's because I did delete a bracket when I was copying and pasting. Sorry about that. There we go. So the point here I was trying to make is that the validate tool only looks at Whittle syntax. It doesn't make any assumptions about the tool or tools you choose to use in your command. That's your tool's job to tell you when you typed it wrong, not Whittle's job. So Whittle can't tell you if you made a GATK error, just like it couldn't tell you if you made a Python error or something like that. But when you try to run it, it'll hit an error and it'll spit back out with its standard error file what the error message is from your tool. So there are two places you can look for errors. One is with the validate command for your syntax stuff. And the second one is with your standard error file in the task when it errors. Any questions on that? All right, so we're going to just revert it back to normal and save that. Now, our very next step is going to be to put this script on Terra. So we have a script already prepared for you. If I go to this Terra folder, you'll see a file called hello.gatk_terra.whittle. And I'm just going to open that up in Sublime Text here before we go to Terra itself. And there's a couple things we've added. So to our input section, we've added this block, which specifies Docker image, memory size, disk size, and preemptible tries. And all of those values are being used in this brand new runtime section of our task. When we're running locally, our tasks run through Cromwell are just using whatever our local computer setup is. But when you run in the cloud, you have to tell it what backend you want. So this one's saying, what Docker image do I want to run on? What memory do I need to run this task? How big does the the memory, the disk size need to be. All of that information is important pretty universally to all backends other than your own computer, because you already have a hard drive in here, you already have RAM in here, so you know it knows exactly what you have. But to request the machine from the cloud, you need to give it that information. The last one there, preemptible, is something specific to Google Cloud. And I think Amazon has its own version of this, but essentially, a preemptible is a machine on the cloud that you pay significantly less for, but you could be kicked off it at any point. So we set these preemptible tries in there, and it typically saves us money because especially for our shorter running commands, we're able to get on that cheaper machine and finish what we need to do and get off before we can get booted. I will say, if you have an individual task that runs longer than 24 hours, 24 hours is the max amount of time you can be on a preemptible. It'll boot you off after 24 hours no matter what. So if you have a long-running task, don't put it on a preemptible. Don't even try, you'll waste money. So with this new runtime setup, you could run this script exactly as it is right now on your computer. And Cromwell is intelligent enough to know to ignore preemptibles as an input, because you can't be preempted from your own computer, hopefully. You can't get kicked off. So in that way, Cromwell allows you to run one script in both places. Now, I'm going to have to ask you to take my word for it, because we're not going to run this locally. And the reason why is because we are currently running inside a Docker image, and our Docker image doesn't have Docker installed inside of it. So it can't then call another Docker image. And because of that nested logic, we're going to just take this one straight up into the cloud. Yes. Yeah. So if you set up your environment with the GATK jar, you could probably run this. Feel free to try. I'm not going to walk through it today, though. The next bit to show you is this hello.gatk.inputs.json. And when you look at this, you'll notice it's quite different from our previous one. So instead of referencing our data bundle, it has these GS URL links, which are all links to files that live in the cloud. Now, ordinarily, if you wanted to run on your own input BAM and input BAM index, you'd need to upload those files to the cloud. But since we're providing all our samples for you, and we didn't want to have 1,000 copies of NA12878 for every workshop we run, we've just uploaded it to a public bucket so that you can access it and run it that way. But your files that you want to run on have to be in the cloud. They can't be local to your machine in order for you to run on the cloud. We've also given values for our new runtime options, and you'll see that the Java option at the very top is still the same. Any questions on this? Okay, then let's go over to Terra. So if I open up my Chrome window and go to app.terra.bio, we're going to start out again by cloning a workspace. So go to View Examples from your home page, and the workspace you're looking for is called GATK Tutorials-Pipelining. And it looks like it's almost at the very bottom on the right column. It's the second from the bottom. All right, so this is our workspace. And the first thing we're going to do is clone it. And when we clone it, we want to append it with our name or some other identifier you've been using. And you'll select your free credits billing project. And go ahead and click clone when you're ready. I'm not having you start up a notebook runtime today. We're not going to be working in notebooks, so you don't need to worry about that. Actually, we'll be working in one later, but we don't need it right now. So go ahead and click clone. Now, the instructions for everything up till now have been in that PDF I gave you. And the instructions for this section are all in the dashboard here. So if you wanted to run through this again later, you can follow the instructions here on the dashboard. So it's all right there. On that note, I'm going to switch my notes here. Okay, now that we have this, we're going to open up a new tab with Terra in it. So you'll leave your pipelining workspace alone, and we're going to go back to the Terra homepage in a new tab. Then we're going to click on this hamburger menu here, and we're going to go to the library section and go to workflows. So this takes you to a list of methods or workflows that you can copy and use in your own workspace. So one way you can start is by just cloning a full workspace, but if you're only interested in specific workflows, you can just grab those individual ones you want from here. For our purposes, we're going to be uploading a new one. So you can upload workflows to either DocStore or to the Broad Methods repository. So we're going to use the methods repository here for today. So if we click on that, you'll be directed to this page. And now this page looks considerably different from Terra. This is in our legacy app called FireCloud. It's a part of the website that we haven't yet ported over, but we're still working on it. And it lists all the public methods you can access, or featured methods, or my methods is the ones that you've created. So for our purposes, we're going to hit create new method. Actually, I need to sign out and sign back in with my other account. Otherwise, I'm going to have trouble. There we go. So now we're going to create a new method like this. The namespace is another word for publisher. So you may be publishing on behalf of your lab and you put your lab's name there, or you may be publishing on behalf of yourself and you put your own namespace there. So I'm going to put my namespace there, and I'm just going to do _1 because I already have a namespace that I use on my other account, which I won't be able to access because my other account owns it. The name over on this side is the name of the workflow that we're uploading. So for us, we're going to call it hello. And then I said HC. Oh, sorry, hello GATK is what the workflow is called. Used to be called hello haplotype caller, but that was way too long. So once you have your namespace set and your name, you're going to click this load from file button for the Whittle. Important to note, you can also just type your Whittle in here if you're interested in that, but it's easier to just load from file. So I'm going to navigate to my bundle. It'll be under the Terra folder. And then you're going to select this hello GATK terra.whittle. That's what we're uploading. So when you click open, you'll see that it populates in this field here. It's got some nice syntax highlighting going on. You can additionally put documentation in with your workflow, and I highly, highly recommend putting in documentation if this is a workflow you're writing yourself. It's going to make it much easier for other people to use your scripts if you're interested in sharing them. This synopsis option is typically a quick 80 characters or less synopsis of what this workflow does. Again, like documentation, highly recommend it. We're not going to fill it out today. And then the snapshot comment is the last one. It's also optional. If you're familiar with version control, things like GitHub, a snapshot comment is something where you make a note about what you've changed in the file. So say, for example, tomorrow I discover that there's an error with this particular Docker image I'm using, and I say, I'm changing the Docker image. That would be my snapshot comment, was changing Docker image. So we're leaving all three of those blank down here, but go ahead and hit upload when you're ready. That will take you to this view of your method. If you click over to the Whittle tab, you'll see your script here. This configuration section is blank so far. We haven't run this yet. We haven't configured a JSON file of inputs for it. So we're just going to leave that blank. You also have some other options to clone this, edit it. Redact means to not allow it to be published anymore. But what we're going to do is export it to our workspace. So go ahead and click this blue button in the upper right here. You don't have any method configuration, so we're going to choose use blank configuration for now. We're going to say the name is hello GATK, this root entity type. So remember how I mentioned you can have a variety of different tables in your data tab. These are a list of all the default tables that were available to you in FireCloud. For our purposes, we're just going to leave this as participant for now because we're not using any data tables. We're just giving them file paths. But that's where you would select what data table you want to use. And then you choose your destination workspace. So if you click here, it's going to give you a list of all the ones you have available to you. If you have way too many workspaces, you often will want to search. That's why I like to use my identifier of my name, because often other people share workspaces with me and they don't have my name attached to it. So that's one quick way I can filter down to just the ones I created. The one I'm interested in today is this pipelining one here. So we're going to select that, the pipelining workspace that we just cloned. And you'll hit export to workspace. So once it says export successful, you're going to say, yes, you want to go to the edit page now. And that will take you all the way over to your workflows tab in Terra in the workspace you just imported it to. So just the place we need to be. All right. So now we are going to run this workflow. The first thing we need to do is upload or to fill out our inputs here. So this is your configuration. Configuration means filling out your inputs and outputs. And one way you can do that is by simply typing it in. So you can click into each individual box and type what you want. But since we created this on our local machine, we presumably already have a JSON file. There's a nice, easy way to upload a JSON and it'll auto-populate these fields. So if I hit, if I hit this upload JSON link here up in the top of the input section, it's going to pop up this field. You'll navigate to your bundle again if it already isn't there, and down to the Terra folder. And you'll notice it only allows one option, which is this Terra inputs JSON here.
Okay, so now that we've all been fed and we feel good, it seemed like it would be a good idea to talk a little bit about what Docker is and how we use it and why it's important. We've been dealing with Docker all week, and some of us to more success than others. But it's actually a really useful tool for packaging up the tools that you want to run and not needing to worry about how to run them, how to get the prerequisites for them, how to install other things. With containers, as we'll see, all you have to do is get the container and run it, and you have all of the software you need in order to do your analysis. So before containers, before virtual machines, with regular software, the way that you would run your data is you would install everything onto one machine or one cluster, and you'd have to share time. There would be physical resources. Everybody has their own folders, and you can have conflicts with pre-installed software and other things that are already there, and it has a lot of overhead, and there's a lot of difficulty there when you have multiple tools that require, for instance, different versions of the same underlying program, like 2 different versions of Java. If you need to have a tool that runs with one and a tool that runs with another, it's complicated to do if there's only one machine and one system that you install everything on together. It's also difficult to scale it up if you have to have a lot more of them or if you want to test a lot of things. Now with virtual machines, some of that goes away. You can create what is effectively a machine but is all software, and will run on whatever platform you want to run it on, and it'll be whatever environment you want. So you could run Linux virtual machine on your Windows machine, or a Linux virtual machine on your Macintosh machine, or an Apple virtual machine on a Linux box. It doesn't really matter, because you have this virtual machine and it's all contained inside a package. You can run it wherever you want. And in the cloud, this has been sort of the state of things for a long time, where you have sort of an on-demand system that will spin up a virtual machine for you. And these are hypervisors is what they're called. On demand, or will keep track of virtual machines for you if you want to run them. In a lot of production environments, like large companies where people have terminals that they don't bring home, virtual machines are used for that. In the cloud, it lets you do the same thing, spin them up and then do something and then wind them down. And if you're using them in the cloud, often the payment structures that go along with them are by how much you use them, how long the VMs are up, and how big the virtual machines are, with disk and CPU requirements and things like that. So virtual machines are a great way to go because, like I said, they allow you to run on one system, but the actual software and infrastructure you're running can be anything you want. It makes it so that it's very flexible, and it allows you to run software that you might not be able to run otherwise. Containers take it to another kind of simpler level in some sense, where there's less separation between the container itself and your actual operating system. You'll notice that for virtual machines, you have, these 3 layers in the bottom are roughly the same, but the virtual machines also have their own operating system built on top of it. And what the hypervisor and all these other systems are doing is actually pretending to be hardware for that operating system. And what that means is they can tend to be a little bit slower, they require a lot more resources, and you can't run as many of them as you might like if you want to do things like load testing in a big software environment. Containers, on the other hand, use your existing operating system features on their own. And the Docker daemon provides a bridge between your operating system and the container's idea of what operating system it's running on. It's kind of like borrowing resources from your host system directly instead of allocating a whole bunch of resources for this operating system that then get allocated to your applications as this operating system wants. So you need to give it a whole big chunk if you were having a virtual machine, whereas this sort of is able to grab them as it would like. It's not a great analogy, but that's more or less how it works. The result of this is that Docker containers can be very, very, very small. You can have a container that's 10 megabytes if you wanted. Virtual machines, on the other hand, tend to be on the order of gigabytes, tens of gigabytes, hundreds maybe. It's not to say that all Docker containers are small, but they're much more flexible than virtual machines are. So you could, if you wanted, combine virtual machines and Docker images. There's no reason you wouldn't be able to do that. And in fact, that's sort of what we do in the cloud, where we spin up these machine instances on Google, and then we actually tell them to run Docker so that we can run the containers that we're used to running. Because you have this operating system from the virtual machine, there's no difference from that VM's perspective, what it's running. It thinks it's just running any other software. And a system like this allows you to be much more flexible if you have to run things that don't exist in containers and you might need to run them on a different operating system or a different version of your operating system, things like that. And ultimately what this really comes down to is using Docker allows you to package up an analysis or a tool and give it to someone else in a state that will be easily runnable and repeatably runnable by whoever you give it to. So if you've got a tool that you've built and you want to release it like we do with GATK, you can create a Docker image and you can hand that Docker image to someone knowing that if they run the Docker image, they have everything they need to run your software. And because we do a lot of things in the cloud, we don't want to have to worry about, oh, I've got to create this machine in Google and I've got to install this software. Well, it's much simpler than that. We, tell Google we want to run this Docker image and then we can just run our stuff immediately. We don't have to wait for installations or anything like that. We just have to download it. And the reproducibility aspect is pretty important as well. If you're going to be running a series of analyses on a bunch of data that you want to then combine and do a big analysis on, you need to have it reproducible and it needs to be the same analysis. And with a container, that makes it very easy. So the way that Docker works is you have a Docker file that specifies how you want to build an image. The image is this big file that you give around that contains all of your analysis. And then you run it as a Docker container. And the container itself has all of those tools that you've built into the image that you'll want to run to do your analysis. And so like I said, you put anything you want in there. It doesn't really matter. Typically, we have our tools, some runnable scripts and executables, any dependencies we need, and depending on what you're doing, you might want to have some sample data or a README or something so that someone knows what the container is actually for if they're just running it. Now you can go on any of these Docker repositories to find a Docker image that might have what you'd like. I know that in the past I've looked for Docker images for running CUDA analyses so I didn't have to build them myself. And as long as my host machine had a video card, it would work. So there are tons and tons of these images out there that already exist for different kinds of analyses beyond GATK, and even beyond analysis, you can have a Docker image that is very good at, talking to a website. And if you think about the way that Google and Amazon have to test, typically in their test framework for load testing, they'll spin up, 100,000 Docker images at a time to hit their servers to make sure they don't go down. So they're very flexible in terms of the kinds of things you can do with them and put in them, and actually how you can use them as well. And then you've seen how we run them interactively and even run them in a Whittle. And either of these is very, very helpful when we're doing analysis. So this is actually most of a Docker file. It's another programming language effectively, but it's more like a description of what you want to include in your Docker. So this from is, there's this R base Docker image, and from means we're going to start with this image itself. We're not going to worry about how to create all the basics of installing an operating system and installing R. We could start with what someone else has already made. And then we're going to add our own scripts and our own directory, and then by default, when you run the image, we're just going to have it run your script. And that's what these 4 lines are doing. And in that way, you can make a Docker image as soon as you run it, do something, and then exit. So if you have a tool that you're going to want to run a lot, you can just have that be the default argument for your container, and it will automatically just run that every time that you want to run the container. Makes it a little bit easier than jumping in and then going into the right directory and running the thing and then exiting. And so you've seen what it's like to run a Docker container. This is how you would build it. You build it, you give it a name and a repository and a tag. You'll notice that when you were running the Docker image for GATK, it was Broad Institute /GATK and then 4 and whatever the version number was. And that's analogous to what you would put here when you were building it in the first place. So when we build the GATK Docker, this is how we do it. Broad Institute GATK and then the tag name. Just as you see down there. And then you've already run Docker images. It's relatively straightforward at this point, I think. And then if you want to mount something locally, this is how you would do it as well. And again, as part of those exercises earlier, this is what you've already done to get a file path on your folder or your computer into some different folder path in the container itself. And so this is a little bit larger Docker file that we have that builds up a container with R and the Picard analysis set, tool set. And it looks the same. You just start with this Docker image. You make it so that when you open the Docker container, you start in this directory. We want to upgrade our installation base for Linux, and then we want to install R and some other things, some R packages. And then we want to put Picard in there, and this is the whole thing. This would create you a Docker file that would have Picard and R in it. And that's, I guess, the end of that. Any questions about Docker? Okay.
Okay, while I'm getting set up, I'm going to have you clone and start a runtime environment. So go to the homepage of Terra, so app.terra.bio. And we're going to go into the examples again. And this time we're looking for a quick start workspace. So we're just going to search for it. So there are 2 quick start workspaces we have in here. One is about notebooks specifically, and another one is about workflows. So we're going to be using this notebooks quick start here. So you should find a workspace called Terra Notebooks Quick Start, and we're going to clone it. So again, we're changing copy to whatever identifier we've been using all week, and selecting our free credits billing project. Once you've done that, go ahead and click clone. And once you've clicked clone in your new workspace, you're going to start your runtime. So you should have an already paused runtime. If you don't, go ahead and create one. But you should just be able to click Start Notebook Runtime like this. And if you don't have one to unpause, go ahead and create a default one. We don't need any special settings for this, but we can use the settings we've been using all week. So we're just gonna keep reusing the one we have. Yes.
I was trying to install Docker Toolbox,
Okay.
but it's making like a problem. It's making an error with this. I don't know what that
Yeah.
means.
We ran into that error earlier this week. It involves going into BIOS and custom changing some configuration settings, which is a lot of intricacy. So we actually had people download the GATK jar and run with that locally. So you can do that if you'd like. There's instructions in the folder for how to download it and test it, but we can't do it right now, sorry.
No, no, don't worry. I tried to do the GHK way, but it hasn't all the errors. So we used to do that download.
Maybe we can help troubleshoot your error during a break since we're on a different topic right now. Yeah. Okay, so you should have all cloned this workspace now, and if your notebook runtime is started up, it should say running in the corner. For this particular workspace, it was actually just rewritten last week, so it's got some nice fancy graphics to it. Our designer took a stab at improving it, so I'm really happy with how it looks, and hopefully you guys find it informative as well. Unfortunately, I'm not going to have you read it all because I'm here to give you a walkthrough, but if you're running this through on your own, absolutely follow through this. It's going to go over a lot of the things I've been teaching you this week, as well as some additional tips for working with BigQuery, which is actually what we're going to be doing today. So there's one part of Terra we haven't yet looked at, and if we go to our hamburger menu here, under Library, we can select Data. So this is our data library where we have a whole bunch of different cohorts all in one place that you can use this as a jumping off point to access a ton of different data sets. As you scroll, you can see there's quite a few here. The one we're going to be using today is this 1,000 genomes low coverage, and we're using that because it's publicly accessible. You don't need to apply for access or anything, but all of these other ones, they have ways to get access. It just requires an application process, and it's a bit more than we wanted to do today. So let's hit Browse Data on that 1,000 genomes low coverage, and you're taken to this data browser here. So we have a whole list of attributes of the data set that you can filter on. So you've got some overviews of your samples, gender, population, more specific population, various things here. And something interesting is if you click on one of these, for example, I clicked on SC under low coverage center samples. And if I highlight over it, it says 739 samples are in that bar. And if I click on it, it highlights that one and then deselects all these other ones. If I go up to the top, you'll see that it added this to my search. And it says that my cohort of participants from this 1,000 genomes group of data now has 739 participants in it. So if I were building a cohort of data to add to my study that I wanted to parse out just maybe the African samples and just the ones sequenced from this particular coverage center, I could make this selection here, and then what we're going to do is select Save Cohort, and that's going to allow us to work with specifically those 209 participants. So you can make the same selections I did, or if you're interested, you can make a different selection. We're going to be using this in order to build some graphs later, and essentially what we're just showing you here is how to access data that already lives in the cloud. So I'm going to hit Save Cohort, and it asks you to give it a name to create in Terra. So I'm going to name it African_SC because those were the two filters I put on this one. And I'm going to hit Save. And the next thing it's going to ask you is where you want to put it. And you can either choose to create a new workspace or you can use an existing one. We're going to use an existing one and select the one we just cloned. So we're going to go find that Quick Start one, so Terra Notebooks Quick Start, and select Import. And that will take you straight to your Data tab. If I click on this cohort table, this is the cohort that we just added. So African SC, that's the cohort that I selected from my data set, which is the 1,000 genomes. Interestingly enough, you can also select this and choose Open With, Data Explorer, and that will take you back to this view and you can see visually what you selected if you're curious, just to confirm what's in there. But we don't need that right now, so I'm going to go back. Yeah, so if I'm in my cohort table, I check the line of the cohort I'm interested in. Then with these three dots here, I can select Open With and choose Data Explorer. Yep. So now we have a data set in our workspace. Now that we do, we're going to go over to our notebooks and use that. So there are 4 notebooks in this particular workspace. We're only going to be going through these 2 here. This notebook here, Zero Jupyter Intro Optional, is a great notebook if you're not familiar with Jupyter Notebooks. It teaches you a whole bunch of tips and tricks for working with it. It goes a little bit beyond what I've showed you in this workshop, so if you want some extra fancy stuff to do, that's a great place to learn it. But we're not going to go through that today. The other one that we're not going to go through is this number 3, Access and Plot Public BigQuery Data. It's pretty much the same as this one, so I just didn't find it as interesting to show you guys. But you're welcome to take that home with you and run it yourselves. In previous notebooks, we've had our setup portion as part of the notebook. In this particular case, we have a setup notebook that's a separate one. So we're going to show you what that looks like. If I click in on this 1R environment setup here, I'm going to choose Edit to open it up. And it should open up fairly quickly because our runtime is already going. And there we go. This one tells you a little bit more about how things are running. I've already mentioned to you about how the asterisk means that the cell block is running, and then a number means it's finished, things like that. For the rest of these, I did run this yesterday, so I already have the notebook extensions enabled. But for the rest of these, you're just going to run everything in it. One way you can do that is by simply going to Cell and then saying Run All. So we're going to do that for this case because the whole thing is a setup portion. We don't really need to dig into all of it. So we're going to go Cell, Run All. This is installing some notebook extensions like that code folding we've been using earlier. It's also going to install R packages that we'll be using to plot later, as well as confirming that they're loading properly. And then it runs this provenance section at the bottom. So you'll notice if you look up in the corner here, our kernel is not a Python kernel. We're actually using an R kernel for this. And an interesting thing that R can do is use this dev tools thing here to print out the session info for provenance. And it tells you exactly what tools, what packages, and what versions of those packages are loaded into your system. So if you're working with R, you can use this to print out all the things you have loaded. So in case you're trying to take it to a different environment and decide what pieces of this do I really need to take with me, you can figure it out with this. So quite a lot in there. Any questions about this setup portion? Okay. Once that's finished running, go ahead and just exit out of it, back to your notebooks. And we're going to open up this 2 BigQuery cohort analysis. And then select Edit. So before I move into working with the data here, I wanted to talk a little bit about what BigQuery is. So I've mentioned this word, and it's essentially a Google Cloud storage solution where it creates a spreadsheet of structured data, essentially, and it's using this format where it can quickly access the data in such a way that you can use a query. So Google has this 5-minute video on it here, and then it also mentions that 1000 Genomes Project, which is the data set we're using, is stored in BigQuery, but there are a few other ones in there as well. Or not a few, there's quite a few. So you can absolutely go check those out if you're interested in some more information. So, important to note about cost. So you're not paying for storage of this public access data set, but querying the data using BigQuery does have a cost associated with it. This is paid to Google. In the case of this particular notebook, it's only going to cost us a few cents, but there are tools, and we do have documentation about calculating the cost of your BigQuery before you run it. All right. So we've already run the 1R environment setup. There are a couple other R packages we wanted to have you install. So we're going to run this one here, which is our big R query package. BigQuery can be worked with outside of a notebook, but the commands for working with it can be very complex. If you're familiar with SQL or working with SQL databases, then you might find that very familiar, but otherwise we have this nice way to work with it that we're using. We're also installing the Reticulate library and importing OS, FireCloud, and the FireCloud service selector, which we've been using in previous notebooks. So Reticulate is a library that allows us to run Python code inside an R notebook. You'll notice this is kind of a theme in our notebooks. We like to use both Python and R at the same time. So we've shown you a Python notebook where we ran R code with our variant filtering notebook. And for that, we installed a particular library that allowed us to do it. And this is the inverse, where we're running Python code inside an R notebook, sorry. Yep. To import OS? Did you run the one R environment setup? Okay.
I run this one. I don't know how.
So scroll up, because this one errored first. That one failed, that one ran. Oh, sorry, how do I open a new tab? That one.
Sorry.
Oh. Something got interrupted because it looks like it ran once and then deleted and then ran again. So we're gonna just try running everything again. Yeah, go cell run all. Okay, now go back over to this tab and try rerunning this command. Try something. Mm-hmm.
What if this user can't select R as a kernel?
It means they have the wrong runtime. I'm guessing they're still on the Hail runtime because that didn't have R in it, so they would need to delete their runtime environment and just create a new default with all the default settings. They spin up really fast if you use all the defaults, not GATK scripts. Is anyone else getting an error at section 1.2? No? Okay. I just want to see if this is like consistent or not. Okay. I really don't know. Oh, this errored. also failing for the reticulate package. Hmm. All right, I'm not sure. I'm gonna have to investigate that further. Try just following along with me. All right. Okay, so we're going to continue on by setting our project globals. So you've seen these before. I'm just going to run all three of these cells. We're setting up the project variable, the workspace variable, and the billing project variable. You've seen these before in Python. These are the commands for getting them in R. And essentially, it's just looking at your workspace and getting the IDs that it needs to run these later commands, and setting them to variables so that it's easier to call. All right, next we need to get our cohort query. So we imported that cohort table to our workspace, and now we need to run this command to convert our R variable of workspace to a Python variable workspace, because next we're going to be running some Python code. So we'll run this cell to change those variables over. And then in this cohort entity definition here, we're calling those new variables to create an entity. From that entity, we're storing both the query and the attributes. So this cohort query is grabbing that particular query from the entity itself. And then this particular cell is just printing out what's in the entity, so we can see what we have in here. All right, so this entity has a number of attributes, including a query. This is a big query. This is the text that you would write into Google if you were working with Google directly. But thanks to our nice user interface, you were able to just select the things that you wanted in such a way that it created this for you. You also have your Data Explorer URL, so you can copy that URL and you'll be taken back to the Data Explorer page to see what your query looks like. It tells you about the data set, and the entity type is cohort, and the name that you gave it, which for me was African_SC. So this next bit is reading that particular query into a in-memory table called T. And when we run that, we can examine the output. So it looks like somebody forgot to put in text to explain that part, so I'm going to do that on the fly. I'm sorry about that. This first bit is calling BigQuery, specifically the query for your billing project ID and the query that we're passing in. And it's assigning it to this variable T. And then when we go to TT, it's actually downloading the table and putting it in that part. So this table is just storing these two values, and this table is storing the result of when you run this value. So TT has your table of your participant IDs all here, and I believe that's just the number of rows there. So for mine, it's a table of 209, which matches the number of participants I originally selected from my sample. So if you selected the same thing, you should see the same number. If you selected something different, you should see a number matching however many participants were in your cohort. So the query we just ran returns just the participant IDs, which, while helpful, we need additional information to do a real analysis. So this is an example of how we can access more data from the table. So this query is selecting by distinct participant IDs their genders. And we're pulling from the 1,000 Genomes project, and then we're assigning that query into our table data. And then this part is, again, downloading it into a table. So let's run this cell. The output of it is printing the dimensions of the table. So it's showing 3,500 by 2. So this 2 part is the participant ID and gender that it's listing in the 2 columns. But this 3,500 number, now that's much bigger than our 209. So right now it's grabbing all of the participants from the 1,000 Genomes Project and recording down their participant ID and their gender. So in this particular table, we have all of our participants. Now what we want to do is create a merged table. So this new merged table is going to be the intersection of our previous table, which was TT, and our new table called table. We need to come up with better names. These are not very descriptive. And it's going to look at them by participant ID, and for everyone where they match, it's going to merge the gender information from our new big table into our little TT table. So let's run that, and then print out the dimensions of our merged table. So now our merged table has 209 participants in it, and its columns are 2, so it should have one for the ID and one for the gender. So it looks like it worked. All right, now we are going to plot the data to take a look at it. This particular plot divides the group by males and females, and it's plotting our data from the 209 number, so just our participants. So this adds up to 209, that makes sense. And if you selected one of the options for like just selecting male, then obviously you'll only have a male column there. But since mine was the African population and then the SC Sequencing Center, we have both there. So this is a little bit of a look into how you can grab data and query it and build it into a table and put it in a notebook. And right now we're just showing you plotting it, but you could then take that data and do whatever other analysis you wanted with it. So for example, that GWAS we ran on the first day, you might grab data from 1,000 genomes, pull it into your workspace, and then have these tables and work with it that way. The last bit we have is provenance, which just tells us what's in our workbook or workspace's notebook here. And that's it. Are there any questions on BigQuery?
Where do you see the cost of the BigQuery?
So seeing the cost for the BigQuery actually is on a separate website. I don't, off the top of my head, recall how to do it. I know we have a document about it. So if you went to our support center, you could find it.
Okay.
Yeah, if I just go to the dashboard of any workspace, it's going to tell you, oh, no, that's the GATK support center. Anyways, if you go to our support menu, you can look at our documentation and then likely find it there, specifically about BigQuery. While I'm on that note, though, I wanted to show you our GATK support center. So we have our new GATK website, which launched early January. So you can find all your documentation here, and then you can also ask questions to our support team here on the forum. We got that there for you. So if you have any further questions about GATK that we're not able to answer for you today, or maybe you think of them later, you can absolutely ask them there. But if you have questions about Terra, ask them on the Terra Support Center. It's the same team supporting both, but you'll get your answer faster if you ask on the right place because there's a transfer process to get it over to the right place. All right. So that's the last bit of presentation I think I have for you. I had a couple of items to go through to kind of wrap up this day. And then we're going to have a coffee break at 2:30. So let's talk about a few things. So first, in this folder that I've given you, This is the Broad.io GATK 2002. Inside the exercises folder, you'll notice that there's one more here that we haven't gone through yet, which is the Whittle puzzles. Now, these are typically given either as a take-home exercise or as an in-person work-on-your-own exercise. However, we've been having a lot of trouble with Docker and GATK today, so we actually ended up spending more time this morning focusing on that guided Whittle tutorial. So, if you'd like to, you can take this home with you and work on it. It's a series of 10 exercises that go from easy to much more difficult. For exercises 1 through 6, we walk you through building this particular pipeline. It's going to run haplotype caller. It splits out SNPs and indels, filters them separately because they have different hard filtering thresholds, and then combines them back into one VCF. So it's a simple mini pipeline for you to work on. That particular pipeline can be found inside your bundle. So if I go to my desktop here, under the puzzles section, you'll see this hard filter Whittle, which corresponds to exercises 1 through 6. It'll always tell you what file to open. And if I open this up with Sublime Text here, you'll see that it's mostly filled out, but then we have these sections related to exercises. And if you use the document alongside this file here, it'll guide you through what exercises are to fill out which things. So this is a mostly complete workflow that you're going to be filling in the pieces for. Then if you get stuck at any point, we have this solutions folder, which gives you all the answers. It's essentially the back of the book. Try not to look at them if you want to test yourself and work on it. I will say, honestly, the logic is very simple. You can figure it out. So build your confidence by working with the Whittles in the way that they're designed. There are multiple ways to solve things. We've given a solution, but if you come up with another solution that works, it doesn't mean that you did it wrong. If your script runs and it does what it's supposed to, then you did it right. The last thing to mention here is that these are all designed to be run inside the Docker. So if you had special adaptations to run outside the Docker, like you were calling a specific GATK jar, then you just need to remember to mention that GATK jar's location as opposed to the one that's inside the Docker bundle. There we go. All right, so I ran this twice, once with no data entity and once with a data entity, and I named the configs separately so that I could keep both. You do always have that option if you'd like to. You can run the same workflow in a different way with different configurations. So for the one that didn't have a data entities associated with it, I'm going to click in there. And you'll see that there's still no data entity listed, but I can go in and view. If I were working this way and I wanted to see my outputs, I would go to this output section and see the literal GS URL written. And that's the way I can get the file from it, because it's not going to write it back to my data model. Looking at my timing diagram, it looks like this one took 6 hours and 22 minutes to run. So again, that's because we're working with a larger GATK here, or a larger file, base file. If I go back here and look at the other one, I believe the output will still list the direct URL, but we will have another place to access it as well. Yes, so the output still lists the direct URL, so you can always go there to find it if you forgot for whatever reason to declare a variable for it. But if I go here to my data tab and select sample, I can scroll over. Oh, it's not there. Where did I write it to? I might have forgotten to mention where it should write to. But it would show up here in the sample table. It'll be a new column and it'll say output GVCF, and then it'll be a link like this that you can simply click on, and you have the option to download it or do other things with it, up to you. So that's a little wrap up from the pipelining exercise we did this morning. The second to last thing I wanted to show you is, again, this survey here. Just as another reminder, I know I mentioned this yesterday, but for those of you who are here today, thank you for coming. We really are excited to have you, and I think I really enjoyed teaching you today with all the Whittle stuff. I know it can get complicated, but hopefully we all learned a lot. Feel free to take that survey now if you'd like, or I'll be sending out an email after the course with links to a bunch of resources, reminders of where all of the information we've given you over the course of the workshop, links to all that stuff, as well as this link to take the survey again. The last part of our day is a debrief, so a discussion with you guys. We really want to know about what you learned this week. So, what did you learn this week? What did you like? What did you not like? What did you want to learn more of? Are there any outstanding questions you have that we didn't cover or maybe didn't circle back to?
I'm not really get clear with BigQuery uses.
Why to use BigQuery?
Why?
Yeah, so BigQuery is a way that Google stores data in a very rapidly accessible way. So a lot of big public data sets are stored in BigQuery. So if you want to work with those public data sets, you pull them using BigQuery, and then you can use them in a notebook or use them in your workflow. Mm-hmm.
But it's just for datasets, public datasets.
You can also put your data sets in BigQuery.
Oh.
Yeah.
It doesn't matter. It's just a database. There's only, what, like 3,000 samples in there or something. You
Oh,
don't
really?
need to use BigQuery to do it. It's just our Google engineer friends set up, and that's how they chose to do it. We're working on a project now using BigQuery to store variants, so that, we can store all the sample genotype data for tens of hundreds of thousands of samples, all certain positions in the genome, and be able to look up, like, by gene name, or, subset samples by cohort, and things like that. So that's where it really excels, because that's a lot of data. But just, metadata on 3,000 samples,
Yep. Anything else? Any questions, comments?
Well, I learned a lot. Thank you so much.
Great.
It's too much and it's hard to try to
It's a lot.
understand well and follow the instructions. But it's very important to learn at least the basic about different tools.
Mm-hmm.
And for me, the most important is understand that you have the ability to access that kind of tools, and not, for example, the institution can buy big computers. I think it's better try to buy a little bit of
Mm-hmm.
power
Mm-hmm.
with the tools that you learn, you teach us, and well, as I say, it's too much for 1 week, but at least we know when you find the teacher and the tools.
it's a lot, and we hope that you'll kind of remember some things that caught your attention, and then you can go back and
Yeah.
reference the presentations. If you were going into this course with a particular question in mind, like I want to do this analysis, I don't know the best way to do that, then we'd expect you to focus on parts that are specific. Yeah.
That kind of tools
Mm-hmm.
that you can retake when you want.
Yeah.
This workshop has been outstanding. Thanks so much.
Thank you.
the time that you to know this. I think there's a lot of tools and we need a lot of practice. One day we are not getting old, but it was great in this area.
Great.
Thank you for your patience too.
Yes.
It's very hard to set up such different systems. Like at the Broad, we all have one of 2 or 3 different kinds of laptops, and so that's easy for us. But then they're very expensive laptops, and obviously not everyone has those. And so it can be a little bit harder with different versions of Windows and Docker versus Docker Toolbox. And so I'm sorry, we tried our best, but hopefully at least in Terra you can work in notebooks there, and if you end up not running jobs on your own machine, that's okay. Does anyone want advice on my thesis project? Okay.
Great. If there's nothing else, feel free to grab more stickers if you want. There is coffee upstairs, afternoon snack. We'll be around to answer questions. If you have any questions you want to bring to us just individually, not in front of the whole class. But other than that, we're dismissing a bit early today because we got through everything. So great job, guys. And thanks for having us.